Alright, we're going to be going through another reaction here on just deciding whether we've got a strong base or nucleophile or a weak base or nucleophile, determining what reaction will follow after that, and then the mechanism for that reaction. So we've got a 2-bromopentane here, and it's going to be reacting with a sodium methoxide. First off, what we're going to do is we're going to look at our sodium methoxide and determine whether that's a strong base or a weak base or a weak nucleophile or a strong nucleophile. So when I look at this, the first thing I think is that we've got an Na plus and then a negative methoxide there. What this tells me is that this right here, since it has a negative charge, it's most likely going to be a strong base, and strong bases are strong nucleophiles. Knowing that, I know with a strong base and a strong nucleophile and a secondary carbon, that we can go through an Sn2 or an E2 reaction. So, what are the mechanisms for these? Well, I know they're both concerted. So, I'm going to start with the Sn2. All concerted means is that we are not going to see any rearrangement because there is no carbocation formed. So what we've got here, I'm just going to draw the methoxide for simplicity, is we've got this negative methoxide here, this anion, if you will, and it sees this opening on this electrophilic carbon. So these two electrons here are going to come up and they're going to hop right on this carbon, and as that's happening, this bromine is going to pull off these electrons that were on the carbon before, and what you're going to see is that molecule right there is your product. Now this is the Sn2. Now for our E2, what we're going to get is this is going to act as a base rather than a nucleophile. And what we're going to have is this bromine here. And we're going to be looking at the hydrogens on the adjacent carbon. So we've got 5 here that we can choose from. But we're going to remember a little trick that Zaitsev taught us, in the fact that when we make an alkene, we're going to want to make an alkene on the most substituted, between the most substituted carbons. That is going to be the most stable alkene, and that will be the observed product. So we could make one in a concerted effort right here. And that would form a double bond between these two carbons. But what we've got here is we've got a primary carbon and we've got a secondary carbon. And then let's see what else we could do. If we didn't take that route, if we took off one of these hydrogens instead, say this one, and then this bond moved over here, and then that moved up to bromine, we would have a double bond here. And it looks like on this one we've got a secondary carbon, and on this one we've got a secondary carbon. Since E2 is concerted, there can be no rearrangement because there's no carbocation formed. So it looks to me like this is going to be the product we're going to have. And this is, of course, for E2. So just to cover that again, the reason I chose E2 is because I looked at what we had here as our solvent, and I said, it looks like an Na plus and a negative methoxide here, which that's going to be a very strong base, because the opposite of it is going to be a weak acid. Methanol is a very weak acid, so that's definitely going to be a strong base. Say, okay, so I got E2 or Sn2, let's look at the carbon. The carbon is secondary. So that means we're going to have a mixture of E2 and Sn2. So these are going to be our two products. So hope that helps.